Welcome back, ladies and gentlemen. Today we're going to take a look at our 6.2, 6.5, and 6.7 review, and we'll see how far we can get. So for the first one here, we have a function, okay? You always want to write a function in standard form first. Let's take a look at the directions here. Use synthetic substitution to evaluate the polynomial function for the given value of x, then state the degree, type, and leading coefficient of the polynomial. Okay, so my highest degree here is the x to the fifth. So the first thing I'm going to write down is negative 4 x to the fifth plus 5x squared plus 2000x plus 8. Okay, so if we take a look at that, so now that we have this in standard form, we can label the type. The highest degree is 5, so that is going to be kintic. Okay, our degree is 5. Okay, they go together. Our leading coefficient's number out front. Please include your sign. Cool. Now we're going to evaluate it for this value of x, 5. So one way we can do this is by doing synthetic substitution. Make sure you put zeros in every time you're missing an x, which I just made a mistake of doing. So x to the fourth, x to the third, 5, 2000, and then 8. Okay. So multiply, negative 20. Okay, add them. Negative 20 times 5 is negative 100. Add down. Negative 100. Multiply. Negative 500. Negative 495. Okay. Negative 495 times 5. Negative 2,475. So negative 475. Negative 2,375 plus 8, negative 2367. And there's my answer. Okay. You could also, alright, if I wanted to go back to the original problem, sorry, here's my standard form. Oop, blowing up. Okay. Okay, you could also just take 5 and plug it into everything. So if I would do negative 4 times 5 to the fifth plus 5 times 5 squared plus 2,000 times 5 plus 8, I would get the same thing. Okay? So just something that you could do if you'd like. That's a 6, by the way. Okay. Over here is another example of this. I'm going to write this in standard form. Sorry, my hand's in the way. The highest exponent is x to the fourth. So negative 10 x to the fourth minus 80 x to the third plus 8x squared plus 7x, okay? So my type, since it's a 4, is a quartic, like quartz. Degree is 4, leading coefficient negative 10. Okay, I can take negative 8 and plug everything in. This is a kind of a tricky one because if you get all the way down here, it's missing the constant term, so you have to put a 0 at the very end. Negative 10, 80, 0. Negative 8 times 0 is 0, 8. That would be negative 64, negative 50, oh geez, too early in the morning, everybody. Negative 64 plus 7, negative 57, times that by negative 8, 456, so 456. Cool. Okay, so we're all good. And the same thing applies here too as well if you'd like to do it. All right, end behavior. End behavior, ask yourself two things. Is the degree even or odd? And then that's the degree. And is my leading coefficient positive or negative? Okay. So over here, my degree is even. So this is an even. And number out front is positive. So my graph looks like this. Okay, it goes up and up. So, we would write our statement as x goes to negative infinity, as I'm going to the left, y goes to infinity, it goes up. Okay, that's it. As x goes to positive infinity, as I'm going to the right, y goes to infinity, it goes up. Done. Okay, it's really that simple. Now here, the highest degree is the 217, so this is odd. And then in front of it is a negative, so odd negative. That means it starts high and falls. Okay. So as x goes to the left, y is going up. As x goes to the right, y is going down. Okay, so there's a typical end behavior statement. Very nice. Okay, here's an example of long division. All right, so let me show you guys this one here. We're going to write down 3x to the 5th minus 4x to the 4th plus 0x cubed plus 5x squared plus 0x minus 11. And divide that by x squared minus 5x plus 7. What times x squared gives you 3x to the 5th? 3x to the 3rd. So I come in my x third column, okay, and I multiply this to all three terms over here. I'm going to get 3x to the 5th minus 15x to the 4th plus 21x to the 3rd. Okay, if I subtract them, they cancel out. Here, I would get positive 15 minus 4 is 11, and that would be minus 21x to the 3rd, and I bring down my next term. Okay, what times x squared gives you 11x to the 4th? Well, 11x squared. Alright, so I'm going to get 11x to the 4th minus 55x to the 3rd plus 77x squared. Cancels out. 55 minus 21 gives you 34x to the 3rd. 5 minus 77 is negative 72x squared. Okay, here we go again. What times x squared gives you 34x cubed? Well, 34x. So now we're looking at 34x cubed. Okay, 34 times 5 is negative 170. And then 34 times 7 is 238. Okay, so now I get 170 minus 72, which is 98x squared, and then negative 238x. Should be an x there. Okay, last one. What times x squared gives you 98x squared? So 98. Okay, 98x squared. 98 times negative 5, negative 490. And then 98 times 7, 686. Let's see here. So if I subtract that, 490 minus 238 gives you 252x. Negative 11 minus 686 gives you 697. So that would be your remainder. So my final answer is 3x cubed plus 11x squared plus 34x plus 98 plus 252x minus 697 all over x squared minus 55x plus 7. Definitely a more difficult one, but you stick to your guns and you will be fine. Okay, you'll be in good shape. Alright, moving on to the back. Okay, identify all possible rational roots of each polynomial. Guys, when it says identify all possible rational roots, this is your P's and Q's. Okay? P's are the factors of your last term. So, what numbers multiply to give you 18? 1, 2, 3, 6, 9, 18. Okay? What numbers multiply to give you your first term, which is 6? 1, 2, 3, 6. Now I'm going to do P's over Q's. Please do not forget the plus or minus. This matter is very important. Okay? So now I'm going to go about this systematically. 1 over 1, 1. 1 over 2, 1 half. 1 over 3, 1/3. 1 over 6, 1/6. So my 1 is done now. 2 over 1, 2. 2 over 2 is 1. I don't have to repeat it. But I do need 2/3. That's a new one. And then 2/6 reduces down to 1/3, don't need it. Okay, on to 3. 3 over 1, 3. 3 over 2, 3 halves. 3 over 3 is 1, 3 over 6 is 1/2. 6. 6 over 1 is 6. 6 over 2 is 3. 6 over 3 is 2. 6 over 6 is 1. Alright. 9 over 1 is 9. 9 over 2 is 9 halves. This is 3, and this is 3 halves, which I have both of them. And lastly, 18. 18 over 2 is 9. 18 over 3 is 18. Or sorry, that's 6. And then 18 over 6 is 3. So bam, that's all of them. Okay? That is all you are doing. You are not doing anything else. Okay? Stick with that and you're fine. See if I can get this last one real quick. Okay. Find all the roots of the polynomial. You must use synthetic division, no graphing calculators. Okay, the reason they say no graphing calculators is because it's given to you right here. This negative 5.196 and this positive 5.196. Since it's the same thing twice, tells me I probably have a square root of a number in here because you need plus or minus for square roots. This 0.2 is important though. The fraction of that would be 1/5. How do I know that? I look up here and I'm helping myself out. Okay, so I'm going to do synthetic division with 1/5. And again, I got it off of this. So I've got 5, negative 1, negative 135, and 27. Bring the 5 down. Multiply. 1. Add them. 0. Multiply. 0. Okay, multiply. Negative 27. Okay. What you have here is, this can be written as 5x minus 1. Okay, and this can be written as 5x squared plus 0x minus 135. Now, we only want to find the roots, so I have to take 5x squared minus 135 and make it equal to 0. So, if I add the 135 over, divide by 5, let's see here, 35, 7. Square root left, square root right, plus or minus. I can break that down to root 9 times root 3. So my answers are plus or minus 3 root 3 and also 1/5, which makes sense because bam, right there. Okay. Yeah, nothing too terrible there. I went a little quick at the end. I apologize. If you have any questions, obviously feel free to ask. Otherwise, keep up the good work and good luck. We're all counting on you.